Okay, so the first thing we were supposed to do is create the OOBB and have it collide against the other, the other two kinds of collisions and itself. Right now I'm just going to talk about the updates first, and then I'm going to go into the collision tests. So the updates for the OOBB is pretty much just computing those corners, which is just getting the original model's min point AABB and max point AABB, and then applying the world to that, and then just getting the 8 corners from the mins and maxes. In the AABB, I added corners for it, so corners of AABB, and that's so that you can use it as if it was a bounding box. In this case, you don't need to multiply by the world transform since it already does it in its original update from the last sprint. So that's just keeping track of the actual corners. And for the bounding sphere, there was no change. Just added the collision test. So in the P2 math, I'll just go over that very quickly. I have testing AABB and AABB, so I moved it in here. It's just the same as last sprint. It's the intervals of the x-axis, checking to see if there's collision on each axis. Then we have the AABB and the OBB collision, and that's basically what we talked about in class. We get the face normals for the first object and then the second object, and then test each face normal and then the cross products of each normal onto the other one. And I call it by doing the separated axis interval. In this case, the separating axis interval projects it on the line, and then for the set of points that was passed in for A, it'll get the minimum and the maximum for A and store it in A max and A min. It does the same thing for B, and then it just checks to see if there's an interval, if it's within the interval, just like the AABBs. And if there is, then that means that it's colliding on that axis, or it's overlapping on that axis. So then when we do it for the 15, if they all return true, then there is a collision. For the OBB and OBB, it's pretty much almost the same. You do the same process, and you just put in the corners of OBB and the corners of ABB. Then testing the sphere for the OBB, and so yeah, the sphere and the OBB is pretty much what we talked about in class. You get the local coordinates by applying the inverse. You clamp the sphere, you move it back into the world matrix, check if it's within the sphere. If it is, that means it's a collision, or else if there's not, then just return false. So testing sphere with sphere is, we already did this before, no need to talk about it. AABB sphere, already did it, and that's pretty much it. So I'll be showing that it works next. So the first test I'm doing is just the OBB versus OBB. I have the tank which has the OBB atop, and they shoot OOBB boxes of bullets. So I'm gonna go frame by frame. It hits, stops hitting, and there you go. The next test is going to be the ABB, where the top is the ABB and the bullet is still OBB. So go frame by frame, hits, leaves, and there you go. And now the final test, which is sphere versus OBB. The top of the tank is a sphere, and the bullet is still OBB. So it enters, leaves. I'll get a better one. So it enters, and then it leaves the circle. There you go. Okay, so this time I mainly focus on the independent project, but I did do a small demo which is just demonstrating the actual audio so far. And I also just added an alarm to the bullet so that it doesn't keep going on forever. After like 5 seconds it just disappears, but that's also so that I can show the demo. So this is what I was kind of thinking so far for the contract. It's not really the contract itself, it's just me thinking about it. I thought at the very minimum I at least want 2D sounds, which is, as you can see in the features list, playing a sound, stopping a playing sound, and playing a loop sound, stopping that loop sound, changing volume on the individual instances, being able to pause and unpause a sound, and then no sound effects. That's probably something I can do if time permits. However, that's why I said, is this enough already? Because I wasn't sure. If not, then I'll also add the 3D sounds, which would be a little bit harder, but just scope-wise, I'm not sure if it's okay or not. So far, this is kind of my overall system. I'm not very good at UML. I've never done it before. So I'm pretty sure most of this is wrong, but it was just so I can get my head around it. Um, so basically, there's a few things to note. It's that iSound source and iSound are the Erklang provided sound and sound source. So basically, what I'm doing is making Erklang a lot more user-friendly. And memory management, a lot of memory management, because the way Erklang works, it's not very user-friendly. So the way it works is basically if you're gonna just play one sound, let's say a bullet sound, and you're not gonna alter it, it's not gonna be looping or anything, then it'll do the memory management for you, in which it'll play it and then it'll automatically call drop on it, which is the system's way of calling delete on the memory to release it. But the problem if you want to have a looping sound or anything with I think a 3D sound and a anything with sound effects and looping, it gives you back a pointer to that sound, and it does not call drop on it. So you're gonna have to kind of memory manage that whole thing. So then I'm gonna integrate that into the actual system. And I was thinking of doing it kind of like the alarm manager, where it checks to see the closest future kind of alarm per se. In this case, it's the sound, the play length plus whenever that sound got called. And iSound is what's the thing that's actually returned when you play a sound, and if it's looping or something, this is what you have to manage. iSound source is kind of like a master copy of the sound, and I'll explain it right here. So in my asset manager, I have a sound manager, and I have load sound, which just works like the other loading. Just give it a file name, and then the asset name, the assigned name you want for it. Create sound instance. That's the thing I was telling you about, where it gets this and kind of creates a copy of this sound source, and that's just so that you can have each sound being its own instance and not have a global sound. So for instance, if I wanted to play a tank sound and the volume was 1, then if it was global, it would be 1 for every single tank shot sound. But because I have it being instanced, I can change the volumes, or I can add different sound effects to different instances of those sounds. So that's what create sound instance does, is it gets this master copy and it creates a slave copy, I guess. It doesn't make sense. Just a copy. Yeah, so it's keeping track of these sound sources, so just so I can copy it in the sound manager. That's basically what the sound manager does, just loading and creating a sound from the master copy. And the sound system is pretty much the actual working of the engine. We have a start sound engine because you have to initialize the Erklang engine. You have to create an instance of it. And then we have just the kind of like regular things you would expect: set main volume, the delete me for the singleton, play 2D and play 2D loop because I'm only working on 2D sounds right now, and then stop all sounds, just stops all sounds. And the sound is the wrapper I have for the sound source, because the sound is pretty much just a sound source, and whenever I play, I create this sound, and then I manage that. So you have the basic set volume, stop, play, and play looped. Okay, so for the actual sound system, what I've managed to do is get what I told before on the features list. I got looping sounds to play, and then I can also stop them while they're playing. And that was easier than the individual burst sounds, because you can assume that the looping sounds are going to go indefinitely unless they're paused, but still that doesn't mean when you're pausing you don't free up the memory, so it's pretty much just stuck until you call stop on it, and then it'll actually release the memory. So the way it works is pretty much when I have it play the sound and return an instance of the sound created, because each sound object has a pointer to a sound source. Oh no, I'm sorry. Yeah, but it's created. So it's like in the asset manager, it has a database for all the sound sources, the original ones, and each sound object has a copy of that one. So that each sound is independent from the other, so that you can change things like volume for different objects, in case they need to be having different volumes, or even different sound effects for different kind of areas, stuff like that. And what I have it doing is putting into the multi-map, where the key is a string, and that is a unique string for the sound object, because I computed a unique ID for every single sound that's created. And so it pretty much just stores it in that section, so that part of the multi-map, and you'll just keep adding stuff to it, because the way I have it so far is a sound can be played multiple times. So one sound can have multiple active sounds playing. So that's why I have the multi-map. So it's easy to locate all the instances of one sound, or so active playing instance of the sound, just by using that ID. And in order to stop all sounds, I just go through the map, stop them and drop them, because drop is the deallocation function for Erlang. Stop sound works the same way, where in this case you get the lower bound and upper bound of the ID name. Nothing's in between that, so it's just going to be the chunk of active playing sounds that correspond to that sound ID. So you can stop individual looping sounds. And for the demo part, I just have a background music object, very simple, just kind of very roughly done, just to get the point across. And it's going to play a background music, and it's going to be played loop. And the tank shells will either play sound 1 or 2, which is gunshots, but they're different volumes. So it just shows that independence in terms of parameters that you can change. Also, after I think 5 seconds, each bullet will disappear, but and their sounds are looping. So when it disappears, it'll stop that individual bullet's sound. So that was a low sound, and this is a high sound. It'll play twice, and then, or maybe 3 times. So twice. But the background music hasn't stopped, so I have individual sound instances. That's pretty much what I have this week.